I'll have 2 recordings from today, or at least 2. But that was all reviews so far, so.
Will it be an even number or an odd number recordings?
Ooh, I don't know. This is how we'll bet in this class, and then somebody writes a proof for it. Okay, number 3. We don't bet. Gambling is bad.
Gambling is for problem stats.
Correct. Save all of your poker for problem stats, please. And your card playing. Okay, number 3. Oh my gosh, Emily, how is your dad's house in Aiken?
Oh my goodness, Aiken got hit.
I know.
It is like torn up. Like that's such a historic downtown.
Yeah.
It is torn up. Trees are over everywhere. My dad's roof got hit, but it's like a 30-year-old roof, and so he's kind of hoping for insurance right
Yeah.
now. But other than that, I mean, there wasn't significant flooding. It's
Okay.
just everything's torn up.
Yeah.
Fence panels are everywhere. I mean, trees. It's mainly just trees.
Trees everywhere.
And I think power's been out since Friday.
Right.
They just got it back last night.
Okay.
This Aiken have the curfew too.
They do. That's so stupid.
Crazy.
They put a curfew out. 7:30. You can't come out of your house and drive around.
That's not stupid. That's safe. It's dark. You can't see trees down or if the road has collapsed. Right?
Yeah, but it's just like.
And people are going to go rob people because their security is not
I
up.
understand that part, but the other part is like what if you wanted food or something? I don't eat until like 8 at night.
Yeah, well, you got to be a better planner than that, Emily.
But it's like you will be arrested if you're caught. It's like whoa.
I just wanted some food. I'm hungry. But because you're honest, that's great. Most people are not. So, okay, sorry. This proof is weird, but you've got that x isn't 0, which means a isn't 0, so you know that neither of a or b is 0 here, which means you can flip it over like that. You get x is b over a, so x is rational also. Cool? This last one is weird. We will do more with this today, I believe. But if the example that we'll use is like this, so 2 divides a squared, then we want to be able to say that 2 divides a. And like this goes as long as this number is prime. So it makes sense if you think about it, right? If you were to write down all the prime factors of a squared, it would be all the prime factors of a but squared, right? So this is really messy, but you've got, if you assume that p does not divide n, then you can write n as some product of primes where p isn't one of them. Is that making sense? So you're writing n as a product of primes. P is not one of those primes because p does not divide n. Yes? If p was one of these primes, then it would divide n. Okay, so you write n as a product of primes where this p isn't one of them. And then if you raise all of this to a power of k, what happens is that each one of these gets raised to a power of k, but p wasn't one of them, right? Which means that p won't divide any of these because it's also none of those. So you can't pull out a factor of p here because there wasn't one to begin with. And now it's the same factors, just to a different power, a higher power, right? There's faith integration. Okay, so p won't divide the into the k either, because it's those same prime factors that it didn't divide before, raised to a higher power. Is that okay? But we're going to prove Euclid's lemma today, I hope. Pretty exciting, which is this, like it's how we need to be able to use it. We're going to do it with just, I don't know, two numbers, 2 powers, whatever. We'll do it and it'll make more sense than this, but this is the generic version of that. Is that good? Okay. So the other approach to indirect proofs is to prove things with contradiction. This is my favorite way to write proofs. And I have a feeling it'll be some of yours too. But you know how to for an implication to be false, you do to do the negation of an implication. Boy, that's a lot of words. Math is a different language, and if you don't know the language, you're just totally lost. So P implies Q. The negation of that is P and not Q, right? That's the only time that implication is false. You with me? So the way to do this is to assume that you get a false result. And then show that that breaks the laws of math. So you assume the P part happens and you assume that the Q part does not happen. And then you show this can't actually be the case. So it must be that Q does happen. Therefore, P implies Q. Which is kind of cool. It's a roundabout way to, it's an indirect proof. Does that make sense? The idea makes sense? Sort of. So like on this one, we would say, okay, well, let's suppose this isn't true. And then we're going to break math. And then we're going to say, we supposed it wasn't true and we broke math, so it must be that it is true.
And that works for everyone.
Sometimes, I mean, sure. You know, it's a statement. So a statement's either true or false, right? And if you can show that it's not false, you have shown it's true. Right? And to do P implies, or P and not Q is saying, and to show that that's breaks, that's showing that it's not false, right? Which shows that it is true. Yeah? Okay, so let's do some. This is how we're going to, shall we do scratch work or shall we just write a proof? Okay, fine. Janiyah, don't yell at me. Have thought? Yeah, got to put that thinking on paper. I'm with you, 100%. I've just already thought about it, so I'm ahead of the game here, as I should be. So we're going to prove by contradiction. So we're going to suppose not. We are going to assume that the square root of x plus y is not less than or equal to x squared of x plus square root of y. So what would that mean? Yeah, we're going to assume the square root of x plus y is greater than the square root of x plus the square root of y. I don't know why I'm writing that at a slant. Let me fix that. Okay, so ways we can proceed. Thoughts? I can square both sides. That sound good to you? We're assuming that x and y are positive real numbers. We can square both sides. This gives me x plus y is greater than the square root of x plus the square root of y squared. This is x plus 2 times the square root of x times y plus y.
Subtract x and y from both sides.
That can't be. Because this can't be negative, yeah. So this is your contradiction. And the way that the notation for that people use is, oh, Lord have mercy, is like two arrows running into each other. Yeah, I know, it looks like an asterisk. It's, oh my, oh golly. This is worse than when my students all made fun of my lightning bolts. This is two arrows who are running into each other at the point. You see it? Yes? Because this is a clash of things that can't be true, both be true. Right? So my teacher, when I did my proofs class, my teacher told me to draw lightning bolts when I reached a contradiction. But I'm really bad at this, and my students always let me know that. So I don't know. One time I had some training. It didn't get better. So we'll just stick to the arrows.
Then you get to smite the false statement.
I know. And that's what, I mean, like, really, faith integration. Isn't this what we want? But I don't know how to draw a lightning bolt. It's getting worse. Ah! I don't know. It's fine. Janaya, you can teach me later. Okay. So there it is. That's the contradiction. We're going to do a proof now. So let x and y be positive real numbers. So they're going to be an R plus. That means they're not 0. Positive real numbers would be R plus. And, sorry. Pause. Erase. Back up. First thing you want to say in a proof by contradiction is suppose not. That's your, I'm going to prove this with a contradiction. Yeah. It's suppose not. Suppose instead that the square root of x plus y is greater than the square root of x plus the square root of y for all x, y in R plus. Boy, I don't know what happened to my handwriting over here. I'll fix it. Okay? And then we're going to say notice the square root of x plus y squared wording. Sorry. This gives us the square root of x plus y squared is greater than the square root of x plus the square root of y squared. I'm really struggling with the phrasing on this.
I think you were writing and I realized, wait,
that's not me. I'm not writing that hard on my iPad.
We have to say notice this gives us, or we can just say notice.
I don't know. I really don't like the words. I don't like my own proof so far. I'm disliking it a lot.
More rough without that thought process.
You're right, but it's the words that have got me.
Wait, so when it's not equal, instead it's like greater or less than, you can't put it in the same.
Yeah, no, I'm going to, but I kind of don't like that, you know? I think if I didn't have to change both sides, I'd be okay with it. So I'm going to do what Michael told me to do, and I'm going to say then x plus y is greater than x plus 2 times the square root of x, y plus y. 0 is greater than 2 times the square root of x, y. And then I'm going to put right here this thingy. This is a contradiction as 2 times the square root of xy is greater than 0 for all x, y in R plus. it must be that the square root of x plus y is less than or equal to the square root of x plus the square root of y for all x, y in R plus.